Hi guys, this is the second video on using attributes with database. In this video, we'll try to make a small ORM framework using Delphi, FireDAC, and attributes, and we will see how this can simplify our database development. So without further ado, let's get to work. So I'm going to be building this ORM from scratch, and you can feel free to fast forward if you don't want to see me typing. I will fast forward the video where I think you don't need to wait. But in general, you can even watch this video in 2x if you just can understand the code that I'm writing. We have to try and understand that what we are trying to build. In this example, what I'm trying to build is an ORM class which interacts with a table in the database. Now, because this is an ORM, I want a lot of those interactivity with the tables to be dynamically generated, in sense that I will just create a base class and I will give its the table name and its attribute, and I'll give the column names in the fields, and the base class should be able to insert a record, right? That is the basic functionality that we will try to achieve in this example. Now, once you're able to do that, it'll be pretty much writing the same SQLs for other operations. Look into that as we come across the situation. For now, let's just talk about how to write a base class that allows you to insert a record in any table of a given database connection. Let's go this, and what I'll do is, the first thing I'll do is I'll create a new unit, and I'll just save this project. Attributes. Okay, so now that we've set this up in our unit, I'm going to create a type class with db base class equal to class, right? And what that class will have will be some public thing that will have a function called insert, okay, which will return, say, a cardinal value, and I'm going to create something like this, and let's just say for right now I'm just adding a placeholder, execute the insert SQL, right? That's it. What we also will do is we'll have private variables. One is db connection, which will be of the ft connection, and one will be db query, which will be the ft query. And what we need to do is we need to add these units. Can't remember. Connection MySQL. I'll use MySQL here, and so I get all the units, and I'll simply just paste it here because I know that I'll be using these units at some point of time. Okay, so the database I'm going to be connecting to is MariaDB. Now, I personally like to put all my users in this fashion. It's a bit of a OCD that I have, so bear with me for that. And now I've got this, and what I'm going to do is I'm going to create a constructor, and constructor create, and in this I'm going to write db con is equal to tft connect connection dot create, and we'll write nil here, and of course we want a destructor, so we can free this, and db home dot close, and equal, I like to use this freeml right? So let's do that. Now it can't seem to find freeml, so I'm going to put only sys, right, sysutils, and there you go. So now it's done. Let me just compile and see everything is in place. I'll go back to my main form, and since I don't need this anymore, I'm just going to clean up the main form. That's it. And let's compile once again, and so far it's compiling.
Okay, so now that we have a base DB class here, let's try and open up a database. Let's take a rather simple table, something that we can use. And you can see that there's this users table with username, password, full name, is active email address, and all of that, so on and so forth, right? So what we want to do is we want to create a ORM class that uh, that interacts with this table, and it will insert a record dynamically from the fields of the class to the database, right? So we've got our base class design, which is fine. And now let's go in a user, and we call it class, and let it will derive from the class. Since it's got a constructor, destructor, all of that is fine. Now all we want to do is make sure that we create properties, and what we do is we take UID, username, user password, full name, is active email address. All right. So email verified verification. Okay. So let's skip these fields because I think this is enough for us to know. And I'll quickly complete this. And you can see that this is published. I'll just change it to public. And now we have this property. Now, what we want to do is we want to connect it some way to our table name. So let's just call our class to my table, and we give it an attribute, and we know that this is the user's table. So let's give it this attribute, and now these fields, right? What we'll do is we'll give them, you know, the connected fields attribute, right? So we look at this and say, okay, the UID field connects to UID. So let's call it we'll create these attributes shortly, but the field, we'll call it UID. Okay. So I'm kind of putting the cart before the horse right now, just so that, you know, we know that we have to create these attribute classes. Yeah. So remember, these are basically the table field names. These are our property names. Okay, so that's the difference. And now, of course, since we are using this attribute, we should create this attribute class. That's all we need for creating this attribute. And we create one more attribute, which is for the field. Exactly the same thing, nothing different except for right. So now, if you've seen my previous video, you know how attributes get attached and how to create your own custom attributes. So I've created two custom attributes, one that attaches on top of the class as a table name, and one it attaches on each of these uh, fields of the class and connects it with the fields of the table, right? And clearly, we since this class is inheriting from TDU base class, it's got an insert statement. I mean, it's got an insert function. So we should be able to see this function even for this class. And what we are going to do is in this insert class is where we are going to dynamically generate our SQL. So what we've done is in the base class, we are creating a connection and we'll also connect, create a query. There you go. So now that we have created a connection, a query in our base class, and we will, of course, hard coded, but this can be read from an INI depending on what your database configurations are. And now, finally, what we want to do is we want to fill this function with the right code. So let's start writing. Okay, so all the all the code that I just fast forwarded actually ended up looking like this. Now, I think it's best if I explain this code at runtime, and I'll show you how this code, uh, you know, uh, helps us achieve what we want to achieve, right? Uh, to start with, let's just look at this class first. Just a quick recap. This is my user class, which has all the fields. And the way I have used this class is I've got a button here, and on the click of the button, I'm creating the instance of that class. I'm setting the properties, and I'm calling insert. And what insert does is, excuse me, this it calls the base classes insert, which does what it has to do, and finally makes the SQL and then executes the SQL. Right. So that's exactly what it's going to happen. So let's quickly run this and put a breakpoint here, and then put a breakpoint here. Okay, and let's run this application. Okay. So let's go ahead, run this. Click here. Here, the user class gets created. I'm assigning the properties. This is the class properties. I'm doing an insert, and it comes to the parent class because the child class does not implement it, so it comes to the parent class. And what we are doing here is we got the table name from the attribute of the class. So just to make you understand, you can see that this is the attribute and this is the value of the attribute. And you can see this table name has come as the value of that attribute. And now we are iterating through all the fields of that class. So through these fields, we'll be iterating, and we are only interested in fields that have the my field attribute, right? So we've written a conditional thing that, only if that field has a my field attribute, then we know that that's the field that's connected to our table. And here we are, and it found this field and did this. And now you can see the name of the field is UID, and the value is a random number that we generated, which is correct. And what I'm doing is I'm just simply adding that field name and value to a dictionary. All right. And there it goes through all the fields, and you can see is active true. Now it's username, now it's password, and it's going through all the fields. And now we have, and now the dictionary has all the fields and values. Now using the dictionary, we'll go ahead and create, the statement, right? So we'll just go ahead and create the final statement of what we want in the SQL. Okay, you can see this now. So there it is, and values. So is active with one, email address is this. And now it's iterated through the dictionary, and we remove the last comma, and finally we'll create this SQL. And now if we look at the SQL, you can see it's inserted into users, you know, or let me just show it to you. There it is. Insert into users, the field names, and the values. And the SQL, open up the thing, open up users, data, and there it is. This is our record, the 67588. Yeah. And now, okay, so the question is we did all of this uh, for one table, right? Uh, what's the big benefit? Now, the benefit is that you can now create a similar class like this for other tables. And here's a table that I have, which is called SC prices, right? And I've created this table class with the table name SC prices, and I've created operation cost and unit, uh, operation cost and unit. And of course, I put underscore unit because unit is a reserved word in Delphi. So, I have to change this. However, the unit field is connected to the unit column in the database. So I've used that column name here, and that's it. All I have to do is now create this, and now I can go ahead and instead of this, price is equal to p prices dot create, p dot operation key is equal to whatever. Now I run this, and this time I will just simply run it and no problems. Then give us an error or anything. And now if I refresh, you can see this is happening, right? So the important thing to understand is that you need to write this code once, and then all you can do is you can create data-aware classes by using attributes. Uh, Now, of course, you can similarly create function delete, okay, which gives you Boolean. You can create a function update, which gives you a cardinal, uh, and if you just implement this, sorry, okay, so clearly we don't have a UID column here. Uh, so what we can also do is we can say, okay, for this table, this is the primary key column, right? So we can add one more thing that is property called is primary key column, and let's make it Boolean. In the constructor, you just put is primary key, Boolean equal to false, and let's synchronize this. Let's just call it is PK, Boolean false, and just say is primary key column equal to is PK. And we want to break here because we don't need any further iteration. And now we can have this where UID where PK call name is equal to PK call value. Yeah. And once you've done that, dd query dot close in case of it's close, dd query dot exec SQL. Yeah. And SQL, which is exactly what we need. Loaded function request equal to string, whether we need this. Okay, cool. And yeah, so let's see if this works. Okay, so this is the row that we want to delete, or this is the table that we want to delete from. And we have this field called ID. So what we are going to do is we're going to add that field in our class. And this time, what we've done is because we modified our p field to also have whether it's primary key or not, right? Uh, to this one, I've added this is the primary key through, and I've connected, created this property, and I've connected it with this field name, and I've made this primary key true. And now in our base class, we have a delete, and this code you've already seen. And since this is primary key is true, then we take this table name where p column name, and if we take it, and we'll execute in SQL, right? So now we go here and we cardinal free, and here I've created t create. I've given it a value, and I have said p dot delete. Yeah, and we have to use this where variance on where utils. So let's see if we can find this. Look, go to string, and let's do this. Now let's run this again. Nothing. And let's run this. Go up, refresh, and there it is, deleted. So what I've done is I've also created the code for the update function. It's a mix of the delete function and the insert function, where we are using the where condition to update, and the insert for getting the values of the rest of the uh, fields. And now if we go ahead and create a button and write this code where we are giving the ID as 3 and we're giving the new values, right? And then we call update, and let's see what happens. Let's see what happens at runtime. And we go here, and so oops, yeah, and let's go ahead and click this. And, let's see how this works. And there, we've done our used RTTI again to go ahead and create. The most important thing is to see if our SQL is correct, and this looks correct, isn't it? Update SE price set cost equal to whatever values you've given, and let's run this. Yep, works. Let's go here, and here are the new values. So uh, the update function is also working. So this is basically the way you can actually use attributes to create, an ORM on your own. Of course, there are tons of other functionalities that you can add, which is, uh, you can write before insert, before update, just like how data set works, except for you can mix and match your own, business process logic depending on the table that you are using. Uh, this gives us a convenient way of now mapping any table to a class, and the class has a CRUD functionality, embedded automatically. So I hope you found this video useful, and happy coding.